I just received my MacBook, the new MacBook 2015, and I'm going to do some testing and wanted to show you the benchmark results. Now, my MacBook is similar to this one being displayed. In fact, I think it comes in two different models or versions. And the one that I have, if I were to look at the actual about, it shows that I'm running the one with the 1.2 gigahertz. I think that's the main difference between the two. I'll scroll down here to show you. They have the 1.1 gigahertz dual core and the 1.2. So I'm going to do a slightly different type of benchmark testing. Most of the benchmarks I've seen on the internet has been testing games or recording videos or different types of things you would normally do on a Mac. In this case, I'm running a Windows 7 machine in a virtual VM, a virtual machine using Parallels. And so I just want to show you, if I were to close this down, this is actually my Mac running, but then within my Mac, I have virtual machine, which is a Windows 7 running here on my Mac, but it presents itself as a Windows 7 desktop. In addition, I also have remote desktop here to another server. Now this is running a Retina display, which is a pretty high resolution. The remote desktop has some limitations in terms of how much you can control the font sizes. So as you can see, everything is really small. This is having to do with the Retina display. But the benchmark that I'm going to do is actually running a series of SAS programs. I use this tool called StatMark. It's a tool developed by use for performing PQ, which is performance qualification when you install SAS. And what it does is it runs, in this example, you can run various sample programs from SAS Institute. This is the sample programs that comes with the software to show and demonstrate all the different components. I'm going to do the base one as an example. In this case, I run it 5 times, meaning I run it once by itself, and then I run it 5 simultaneous threads of the same program in different directories at the same time, just to see how much it affects the server or the machine. And then I generate a report here. I'll go ahead and start it. So what it does is it kicks off a series of SAS programs. If you look down here, you might see that it's similar to performing an X command. You can see the SAS session. It actually runs a series of at this point is running the first one, which is a single thread. But while that is started, let me go onto the server and do a similar thing. Now the difference here is that the server is a much more powerful machine. It actually has, let's see, 1, 2, 3, 4, 5, 6, 7, 8 CPUs, and has a lot of memory, much more than what I have on my 8 gigs on my Mac. In fact, let me go back and look at what I have on my little virtual machine here. So I'm going to start my performance. Notice I only have 1 CPU, and it's being maxed out because I'm running all these SAS sessions here. And the memory allocated within the virtual machine is very small. So it's truly not an apple-to-apple, no pun intended, comparison. But I'll go ahead and run the same program here, which in essence, being a Retina display, it shows up very small here. It's going to run 5 sessions simultaneously. Whoops, let me specify a location where I want to put this report. Test server HTML. And I'm going to run that. So it's running the same programs on the server. So Let me go back, and you can see it kick off some jobs there. If I were to go back and look at on the desktop side or on my Mac, so I'm going to actually pause the recording, and we're going to review in a few minutes after all the sessions are done. As you can see here, yeah, it's showing that it's running all these SAS sessions all at once. Um, so this is where it's really pushing the system, and I'm feeling the Mac. It feels a little bit warm, not hot, but it's probably pushing the little MacBook. Okay, the validation benchmark has completed, and this is the HTML report that it's generated. And on my local Mac, running a Windows 7 virtual machine, it shows the results of how long it took, 37 seconds to run a single thread, and it took a little longer, close to twice as much when it runs two of the same set of programs at the same time. I measure, in this case, everything from memory usage to CPU. And the interesting part, it has to do with when it's running all 5 threads. So the elapsed time for each one of these was close to 5 seconds, as you can see here. Um, so that is slower than a single thread. Now the server is kind of small, so what I'm going to do is I'm going to copy these HTML and graph files down to my local laptop and put it side by side, because the resolution retina display makes it a little difficult to read. So let me do that real quick. So I'm going to just go ahead and copy these. Essentially, it creates an HTML file and a series of PNG files, which are the graphs, and I'll copy it down to, it's kind of like the FTP, but in essence, I'm going to copy it down here to a local folder on my laptop. As you can see here, for a single thread, it took 1 minute and 33 seconds, as compared to, let me go back to the single thread of the laptop. The single thread of the MacBook only took 37 seconds, whereas it took like 3 times as much, 1 minute and 33 seconds, to complete on the server. So let me completely go down to the 5 threads. So as you can see, the real time of the laptop was close to 2 minutes, 1 minute and 51 seconds. And if I do the same on the server, 1 minute and 36 seconds. Let's compare that once again. 1 minute and 51 seconds and 1 minute and 36 seconds. Well, the server performed pretty well from a standpoint of multiple threads as compared to a single thread, but not significantly better. I mean, this is 36 seconds, 1 minute and 36 seconds versus 1 minute and 51 seconds. But if you were to run a single thread, just one program at a time, it does a pretty good job. If I were to compare the single thread, the laptop actually did a lot better than, it started to get worse, of course, when you have, let's say, 2 threads at the same time and 13 seconds of the server, whereas the 2 threads on the laptop is 58 seconds. So as you can see, if you were to run many jobs at the same time, like a server handling 5 different users, then it makes sense that the server can handle it. But when you're running just a few programs at a time, the laptop actually performed better. Now I was doing a little research and trying to understand why that is. And one possibility, this is only a theory, the new MacBook, when they did a teardown, in this case Ars Technica, and in this case they use an SSD drive, are connected to the actual machine itself, the motherboard. In this case, it's using a unique bus, and is using a PCI Express bus. This is analogous to the PCIe bus that you see on your PC when you take out a graphics card. It uses a PCIe card, and there are many more pins, and the transfer rate of those cards is much faster than, say, a SATA or the traditional bus for a hard drive. So I think a combination of a fast SSD and this bus allows for the laptop to perform quite well um, for SAS jobs, which is a combination of CPU and disk I/O. But in this example, it shows that I/O is pretty important in completing your tasks. So in this example, using the MacBook to perform certain analysis and even development of SAS programs and reports could be very effective, even when you're on an airplane and working completely disconnected from any server.